The first question says, from the list of numbers, write down a cube number. So the cube number over here is going to be 64 because 4 times 4 times 4 equals to 64. Then a prime number, so the prime number is a number which divides by itself or 1. So that's 61, or we could even use 67. Either of these would be the right answer. Question 2 says, a train journey starts at 23:30 and finishes at 7:15 the next day. Find the time taken for this journey. So if we're starting at 23:30, from 23:30 to 24 is 30 minutes. Now from 24, we're going to 7:15. So for 7, we're covering 7 hours. And then to 7:15, we're covering 15 minutes. So in total, that's 7 hours and 45 minutes. And question 3 says simplify 3p minus t minus p minus 4t. So in this, we're going to collect the like terms. 3p and negative p are like terms. So 3p minus p, and then negative t minus 4t. So 3p minus p is 2p. Negative t minus 4t is negative 5t. That's your answer. Question 4 says the scale drawing shows the positions of town K and town L. The scale is 1 centimeter represents 10 kilometers. Find the actual distance between town K and town L. So for this, what you'll do is that you will measure this distance between town K and town L using your ruler. And whatever that measurement is, you will multiply that by 10. Why? Because the scale says that 1 centimeter equals to 10 kilometers. So whatever measurement you take in centimeters for K to L, you times that by 10 and that gives you the actual distance. Part B says measure the bearing of town L from town K. So since it's off town L from town K, so you start measuring from the north of K till the point that connects K and L. So this is the line that connects K and L. So this is the angle that we need to find for the bearing of town L from town K. So you can measure this using your protractor. You put your protractor over here. The center needs to be at this point at the north of K. And then you start measuring your angle in the clockwise direction from north towards this line in this direction. So this will give you the angle. Question 5 says each student in a class of 20 students records the number of coins in their pockets. The table shows the results. Find the median. So first, we're going to divide the total number of students by 2 to get the middle value, which is 10. So where do 10 students come? So for that, we need to start counting from the first point using the frequency. So 3 plus 1 is 4. 4 plus 7 is 11. So that means the 10th student is coming over here in this section. So the median is 2 coins. Then it says calculate the mean. So for the mean, we use the formula sigma fx over sigma f. Sigma means sum. So it's going to be 0 times 3 multiply the number of coins with the frequency plus 1 times 1 plus 2 times 7 plus 3 times 8 plus 4 times 0 plus 5 times 0 and plus 6 times 1. And all of this is divided by the total frequency, which is 20. So that gives us an answer of 2.25. That's your mean value. Question 6 is diagram shows three lines meeting at a point. Find the value of W. So angles at a point add up to 360, which means W is going to be 360 minus 80 minus 90, and that gives us 190 degrees. Question 7 says solve the equation 7 minus h equals to 3 minus 5h. Once again, we're going to collect the like terms, but now on different sides. So the variables on one side and the constants on the other side. I'm going to move 5h over here and 7 over here. So when we move 5h to the left-hand side, instead of being subtracted, it gets added. So it's 5h minus h now equals to 3 minus 7. Once again, 5h becomes positive and 7 becomes negative. So that's 4h equals to negative 4 and h equals to negative 4 over 4, which is negative 1. Question 8 says Sasha buys B books and M magazines. The cost of each book is $12 and the cost of each magazine is $5. Write an expression in terms of B and M for the total cost of the books and the magazines. So 12 times B, because if the cost of one book is $12, the cost of B books would be 12 times B, plus 5 times M, because once again, if the cost of one magazine is $5, M magazines would cost 5M. So total cost is 12B plus 5M. That is your expression. Question 9 says find the size of an interior angle of a regular 15-sided polygon. So the formula for the measurement of an interior angle for a regular sided polygon is n minus 2 times 180 over n, where n is the number of sides. So that's going to be 15 minus 2 times 180 divided by 15, which equals to 156 degrees. Question 10 says, without using a calculator, work out 2 whole number 104 minus 1 whole number 11012. You must show all your breaking and give your answer as a fraction in its simplest form. So let's convert the mixed numbers into improper fractions. We multiply the denominator with the whole number and then add the result to the numerator. So 2 times 4 is 8. 8 plus 1 is 9. So 9 over 4. The denominator is going to be the same when you're converting from a mixed to an improper fraction. Then 12 times 1 is 12. 12 plus 11 is 23. So 23 over 12. Now, when we're adding or subtracting fractions with unlike denominators, we have to make the denominators equal first. And in this case, we have a denominator of 4 and 12. So we can easily turn 4 into 12 by timesing the entire fraction by 3. Remember, you just don't multiply the denominator by the number, you multiply the numerator as well. So it's going to be 27 over 12 minus 23 over 12. Now, since the denominators are same, you can combine it as a single fraction. And that gives us 4 over 12, which simplifies to 1 over 3. That's your final answer. Question 11 says, solve the simultaneous equation. So in this case, you can use both substitution or elimination method. I'm going to try solving this with substitution this time because in the previous papers, it's mostly elimination. So for substitution, I'm going to pick this second equation and I'm going to make P the subject over here. So that gives us P equals to P equals to 1 minus 2Q. I'm going to call this the third equation. This is the first, this is the second. Next, what we'll do is we'll substitute 3 in 1. So that gives us 3 times 1 minus 2Q minus 2Q equals to 7. Expand the bracket. 3 minus 6Q minus 2Q equals to 7. 3 minus 8Q equals to 7. So now we move the 3 to the other side. Negative 8Q equals to 7 minus 3. That gives us 4. So Q equals to 4 over negative 8. And that is negative 1 over 2. So that is one value. Now for P, we will substitute the value of Q in 3. So P equals to 1 minus 2 times negative 1 over 2, which is 1 plus 1, because 2 times 1 over 2 is 1, and minus times minus is positive. So P equals to 2. That's your answer. Question 12 says, rearrange the formula to write x in terms of v and y. So first, we get rid of the cube root on x over y. To get rid of the cube root, we're going to cube both sides. So that gives us v cube equals to x over y. Now we cross multiply y with v cube to make x the subject. So y times v cube equals to x. And that's your answer. Question 13 says, find the nth term of each sequence. So for the nth term, first we need to find the common difference between each, number in the sequence, if there is a common difference. So if we subtract 21 and 13, we can see that we have a difference of 8. We're subtracting 8. 13 minus 5 is also 8. So again, we're subtracting 8. 5 to negative 13, subtracting 8. Negative 3 to negative 11, subtracting 8. So we can see that there's a common difference of negative 8. So once you've identified the common difference, next step is to multiply that common difference by n. So we assume that the nth term is negative 8n. Now using that nth term, let's see if we can find the, numbers given in the sequence. So for the first term, if we substitute n equals to 1 in the nth term that we've assumed to be, negative 8 times 1 is negative 8. Now obviously negative 8 does not equal to 21. So what can we do to negative 8 to turn it into 21? We can add 29 to it. So using this changed nth term, let's try to find the second term. T2 would be negative 8 times 2 plus 29, which is negative 16 plus 29, and that does give us 13. Let's check it with another one if we use the fourth one. So negative 8 times 4 plus 21, that's negative 32. And what does that give us? Negative 3, which is the same as the number in the sequence. Hence, that shows that the nth term is negative 8n plus 29. You can also write that as 29 minus 8n. Either way, it's correct. So for the nth term, for the sequence in part B, we once again check if we have a common difference. So going from 2.5 to 5, we're adding 2.5. But going from 5 to 10, we're adding 5. Then from 10 to 20, we're adding 10. So as you can see, it's being, the difference is being multiplied by 2 each time. It's doubling. So this is not an arithmetic sequence. In arithmetic sequences, we have a common difference. Over here, we do not have a common difference. So let's see if we have a common ratio. So for the common ratio, we divide consecutive terms. So 5 divided by 2.5 is 2. Again, 10 divided by 5 is 2. 20 divided by 10 is 2. So we can see that we have a common ratio of 2. So whenever we have common ratios, that means we have a geometric sequence. So the nth term for a geometric sequence has the formula of T1 times R to the power of n minus 1. T1 is your first term. R is your common ratio. And n, is the number of term, depending on what you're trying to find. So since we're trying to find the nth term, if we substitute the values, T1 is 2.5, R is 2, and to the power of n minus 1. Now, we can further simplify this by rewriting 2.5 as 5 over 2. Now, if you remember the rules of indices, if we move a number from the numerator to the denominator or vice versa, the power becomes positive. The power changes, like if it's positive, it becomes negative. So over here, if we move 2 from the denominator to the numerator, the power will change to -1. So this is what we have right now. 5 times 2 to the power of -1 times 2 to the power of n minus 1. So we can combine these 2's because they share the same base. So whenever similar bases are being multiplied, we add the powers. So that's 5 times 2 to the power of n minus 2. So this is your simplified version for the nth term. You should get a mark for this as well because technically speaking, it's the same thing. But it's always better to simplify it if possible. So this is the fully simplified version of the nth term for this sequence. Question 14 says A, B, C, and D lie on the circle. TAS is a tangent to the circle at A. Find the value of x. So if you notice, AB is a chord, and we have angles C and D coming out of the same chord AB. So if you remember, angles in the same chord have the same measurement, they're equal. So x would also equal to 41. Then it says find the value of y. If you remember the alternate segment theorem and focus on triangle ADB, if this is 41, this will be 41. If this is 37, this will be 37. And this would be 180 minus 41 minus 37. Hence, angle y is the same as 37. Part B says P, Q, and R lie on the circle center O. Find the value of W. So another circle theorem question. If you remember the circle theorem where we say angle at the center is twice the angle at the circumference. If this is x, this is 2x. So we're using the same theorem over here. Angle at the center is twice the angle at the circumference. So this angle outside is 2 times 115. So 2 times 115 is going to give us 230. So to find W, we do 360 minus 230, and that gives us 130 degrees. That's your answer. Question 15 says the box and whisker diagram shows information about the heights of some plants. Find the median height. Median height is this one in the middle of the box, which is equal to 28. Find the interquartile range of the heights. This is your lower quartile. This is your upper quartile. So lower quartile is 20, upper quartile is 53. Interquartile range is 53 minus 20, and that gives us 33. So 33 centimeters is your interquartile range. Question 16 says calculate the shortest distance from C to AB. This is a very common question, and you can easily score your 3 marks in this. Shortest distance from C to AB is your perpendicular distance from C to the line AB. This thing. So what we do is that we can use this right angle triangle over here and calculate the shortest distance from C to AB. If we call this M, basically we're going to use the triangle CAM to find the shortest distance. This is our X. So we have this as 17.2. We have this as 33.14. So using SOHCAHTOA, we can see that we have the hypotenuse, we have the angle, and we need to find the opposite. So sine. Sine of 33.14 equals to X over 17.2. 17.2 times sine of 33.14, and that leaves us with a value of 9.40 centimeters. That is the shortest distance C to AB. Question 17 says simplify 18x to the power of 18 divided by 3x cubed. So 18x to the power of 18 divided by 3x cubed. Once again, the rules of indices. When we're dividing similar bases, we subtract the powers. So we divide 18 and 3 normally. 18 divided by 3, that's 6. And for x, we subtract the powers. So that's 6x to the power of 15. Then part B says 125y to the power of 75, whole power 2 over 3. So whenever you have a power outside the bracket, you distribute that power on every term inside the bracket. So now 125 will also have a power of 2 over 3, and y to the power of 75 will also have a power of 2 over 3. So 125 is basically 5 cubed. So that's times 2 over 3. And if we simplify this, we're basically multiplying 75 with 2 over 3. So 5 to the power of 3 times 2 over 3 gives us 5 square, which is 25. And y to the power of 75 times 2 over 3 gives us a power of 50. So the final answer is 25 y to the power of 50. Question 18 says two mathematically similar solids have volumes 81 centimeter cube and 24 centimeter cube. The height of the solids are measured. The height of the smaller solid is 4.8 centimeters. Calculate the height of the larger solid. So if they're mathematically similar and we're talking about volumes, so the formula you need to remember is that height 1 over height 2 whole cube equals to volume 1 over volume 2. This is the condition for finding volumes for similar solids. if we're talking about areas, then instead of cubing the ratio of the heights, you square it. That's the only difference. So we know that the smallest solid, let's call that H1, 4.8 is the height, and H2, which is the height of the largest solid we're trying to find. So that makes V1 24, because that is smaller in measurement, and 81 is V2. So we cube this 4.8 whole cube over H2 cube equals to 24 over 81. So 4.8 cube times 81 cross multiply equals to 24 times H2 being cubed. So 4.8 cube times 81 divided by 24 whole cube equals to H2. So we're doing everything in one step. And that leaves us with 7.2 centimeters as the height of the larger solid. Question 19 says y is inversely proportional to root of x plus 2. When x is 2 and y is 3, find y in terms of x. So if it's inversely proportional, that means if x is increasing, root of x plus 2 is decreasing, or vice versa. So if it's inversely proportional, we write it as 1 over root of x plus 2. And when we remove the sign of proportionality, we have y equals to k over root of x plus 2. K is your constant of proportionality. So once we have created this equation, we need to find the values of k using the given values of x and y. So y is 3, k is what we're trying to find, x is 2. So 2 plus 2 over here. So that's 3 equals to k over root of 4, which is k over 2. That's 6. So y equals to 6 over root of x plus 2 is our equation for y in terms of x. Question 20 says solve the equation tan x plus 2 equals to 0 for x is between 0 and 360. So first thing, we'll make tan x the subject. So 2 goes to the other side and becomes negative. Then we take the inverse. So tan inverse of negative 2. So that gives us a value of negative 63.4 degrees. Now this negative 63.4 shows that tan exists in the first quadrant and the last quadrant. So here and here. This is 63.4 and this is 63.4. So the angles we're trying to find are this, because we always start measuring in anti-clockwise direction from the x-axis. So this is the angle we're trying to find, and this is the second angle. So for the first angle, we will do 180 minus 63.4. Now over here, if you notice, we're not writing it as negative 63.4, it's positive. That's because that negative sign was used to identify in which quadrant the angle would be, which is in the second and the fourth quadrant. So when you're trying to find that angle, we're not doing 180 minus negative 63.4. It's just going to be 180 minus 63.4. So that is going to give us 116.6 degrees. And for the second one, we subtracted from 360 now. So that's going to give us 296.6 degrees. So that's your answer. Next question says the Venn diagram shows the number of elements in each region. use set notation to describe the shaded region. So if you look at the Venn diagram, we can see that the shaded region includes B and C, but nothing from A. So that means it's B union C, all elements in B and C, intersection with A complement. So whatever elements that are common between A, B, and C, they're not included because we have completely excluded A based on the shading. Then it says find the number of A intersection B intersection C. So that's this. The elements that are the only elements that are common between A, B, and C. Question 22 says diagram shows a cuboid with a diagonal PB. Calculate the angle between the diagonal PB and the base ABCD. This is the diagonal. And the angle that they're asking for is this one. This is the angle between the diagonal PB and the base. So first, we need to find the length of DB. And we can find that using this triangle ADB, because we know in a rectangle, all the angles are 90 degrees. So this is a 90-degree angle. This is a right angle triangle. If this is 5, this is also 5. So DB, DB square would equal to 5 square plus 12 square using Pythagoras theorem. Pythagoras theorem is always used when we have two given sides and they want us to find the third one. So that's square root of 25 plus 144, which is square root of 169, and that is 13 centimeters. That is your dB. Now, if this length is 4, this would also be 4. So if we look at this right angle triangle, this is P, this is D, this is B. 4 and 13, and this is what we're trying to find. And this is 90 degree. So since we have two lengths and they want us to find an angle, we will use SOHCAHTOA in this case. So looking at SOHCAHTOA, we can see that we have the opposite, we have the adjacent, so tangent. Tan theta equals to 4 over 13. Theta equals to tan inverse of 4 over 13. And that gives us 17.10 degrees. That's your answer. Question 23 says write x squared plus 8x minus 7 the form of x plus a whole square plus b. So a very simple way of doing this is that we can find the line of symmetry of this equation first. The line of symmetry is basically your, x coordinate of the turning point. Line of symmetry has the formula of negative b over 2a. Now what's b and what's a? The quadratic equation comes in the sign form of ax squared plus bx plus c. So if we compare our given equation to this one, we can see that a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So a is 1, b is 8, and c is negative 7. So if we substitute that over here, negative 8 over 2 times 1, that gives x as negative 4. So this is our value of a over here, negative 4. Now, so x equals to negative, that is the turning point. So x equals to negative 4 is the x coordinate of the turning point of this quadratic curve. To find the corresponding y value, we substitute it back into the equation. So y equals to x squared plus 8x minus 7. So that's going to be negative 4 whole square plus 8 times negative 4 minus 7. That's 16 minus 32 minus 7. And that leaves us with negative 23. So the turning point is negative 4 and negative 23, which means our equation is going to be x plus 4 whole square minus 23. Now, why is it x plus 4 whole square, not negative 4? That's because the completing square format is basically y equals to x minus h whole square plus k. So always negative in the bracket. So since our x value was negative, so minus times minus is positive. So it becomes x plus 4 whole square and then minus 23. This was one way of doing it. The other way of doing this is if we do x squared plus 8x minus 7. Now, basically, this is what we're trying to complete the square for x squared plus 8x. So we know that a plus b whole square is the same as a squared plus 2ab plus b squared. So if we compare this to this, our a squared is x squared, our 2ab is 8x, and b squared is what we're trying to find. This is the question mark over here. So if we compare these, a is x, 2ab is 8x. So replace a with x, so 2xb equals to 8x, and x would be 4. So to complete the square, we need to add b squared over here. So x squared plus 8x plus 4 squared, because b was 4. And then we do minus 4 squared as well, and then the negative 7 comes as it is. The reason we're doing minus 4 square as well is because plus 4 square is a new term that we've introduced in the equation. So if we're introducing something new that's being added, we're supposed to subtract it as well to maintain a balance in the equation. Similarly, when we were, converting the denominator for fractions, we would not just multiply the denominator with the number, we would multiply the numerator as well. So that was also done to maintain a balance in the entire thing. So this is exactly by subtracting b squared as well, not just adding. So now this is your complete square, which is the same as a plus b whole square. Hence, you rewrite this as x plus 4 whole square. And this remains outside for this part. So negative 16 minus 7. And that's x plus 4 whole square minus 23. As you can see, we got the same answer using both the methods. So whichever method you're comfortable with, or if you've learned some other method in school, just stick to that. Next question says, a rectangle has an area of 150 meters square, correct to the nearest square meter. The length of the rectangle is 22 meters, correct to the nearest meter. Calculate the upper bound of the width of the rectangle. So the area is correct to the nearest square meter. So degree of accuracy divided by 2. So for the area 1 over 2, that's 0.5. So if you found the upper bound of area, that's 150 plus 0.5. And lower bound of area is going to be 150 minus 0.5. So that's 150. That's 150.5, and that's 145.5. Now for the length of the rectangle, correct to the nearest meter again. So we do 1 divided by 2, which is 0.5 again. So upper bound of length would be 22 plus 0.5, and lower bound of length would be 22 minus 0.5. So that's 22.5, and this is 21.5. Now, area has the formula of length times width. We're trying to find the width. So width would be area divided by the length. Now, for area divided by length, they want the upper bound. So that means area would be upper bound and length would be lower bound. So upper bound of the area is 150.5 and lower bound of the length is 21.5. So if we divide this, what we get is 7.23 centimeters. That is the meters, sorry. That is your upper bound of the width. Question 25 says 3x minus 2 minus 3xy plus 2y divided by 1 minus y squared. We have to simplify this. So in the numerator, we're going to factor by grouping, which means we're going to divide the first two terms in a group and the last two in another group. So in the first group, we have 1 common, so 3x minus 2. And in the second group, we have negative y common. So negative y bracket 3x minus 2. Now for the denominator, you can see that it's difference of perfect squares because 1 is 1 square and y is being squared. So difference of perfect squares is a square minus b square, which is a minus b times a plus b. So that's 1 minus y bracket 1 plus y. So now between 1 and negative 1, we have 3x minus 2 common. So when we take that common, we're left with 1 minus y inside the second bracket. And now if you notice, we have 1 minus y in the numerator and denominator. So those get cancelled out because they're basically being multiplied to the other brackets. And we're left with 3x minus 2 over 1 plus y. If the brackets were being added to the other brackets, then we can't cancel them out. Cancellation can only take place if, there's multiplication happening in the numerator and denominator. So 3x minus 2 over 1 plus y. '26 says in the diagram OA equals to A, OB equals to B, AK is to KB is 2:1, OK equals to KC. We have to find AC in terms of A and B in its simplest form. So I would like to begin with finding AB first. So AB is going to be OB minus OA. So that's B minus A. So we just found AB. Now in the question it states that AK is to KB is 2:1. So if we find AK would be 2/3 of AB. So that's 2/3 of B minus A. And KB would be 1/3 of AB, which is 1/3 of B minus A. Why did we multiply it with AB? Because AK plus KB is AB. So AK and KB are a part of AB. So if this portion is 1, this is 2, the entire thing is 3. So it's basically what we do when we're solving questions of ratios. We add the numbers in the ratio, make that the denominator. And for whatever part we're trying to find the measurement, that is the numerator. So we have expressions for AK and KB. Now we need to focus on AC. So they've said that OK and KC are basically the same. So what we can do is that we can find OK. So for OK, we can do OB plus BK. OB plus BK. So we're going from here to here to find this. So OB is B, BK is going to be negative 1/3 of B minus A, which will become 3B minus B plus A over 3, which is, if we move this over here, that's 2B plus A over 3. That is okay. So KC is also the same as OK. So that's 2B plus A over 3. So to find AC now, we can do AO plus OC. Yeah. So AC is AO plus OC. Now OC is twice of KC or OK, whichever you want to use. So AO is negative A plus 2 times 2B plus A over 3. So negative 3A plus 4B plus 2A over 3. And that gives us 4B minus A over 3. That is your AC in its simplest form.